chair number by a name, not as a 0, 1, 2, 3. First chair is by some name. Second chair index is by name. That is what we are actually doing here. So what language internally does is the string has a ASCII value. String has a ASCII value. Each ASCII character is a byte. And that byte has a value, right? Essentially, every ASCII character has a value that is treated as address value. So string is converted into ASCII value. So when I write string name equal to SV, name has a equivalent ASCII. That value is what gets used as an index here actually. String is finally treated as a some value by converting to ASCII that gets used as a value. Now let us talk about various associative array methods. Array methods are num, delete, exists, first, last, next, and previous. Various methods are there. Even though associative array is dynamic in nature, new is not required. Understand? Like Q also we didn't use new. Did we use new for Q? Same thing for associative array. We don't need to use new for associative array. Let's read through these methods once. Can you please read through them once, everyone? What num does? Returns the number of elements in the associative array. So it is like a size in other. Num is same thing. Delete does what? Delete all array elements. Also possible to delete only one element. So same as Q. In associative array also you can delete one specific index. You have to pass the index as the argument. What exists will do? Let's say if I want to check in this room, chair number 35 is present or not. Then I will say training room 3 dot exists chair number 65, whatever. If it exists, this will return 1. If it doesn't exist, it will give 0. Returns 1 if element exists at a given index, or returns 0 if it doesn't exist. First will do what? Returns the first index value in the array. See, first index need not be 0, right? It can start from index number 10. So it will return 10 as the value. Last will give you what? What is the last index? Returns the last index value in the array. Next will give you what? Returns next index value in the array for given index. If I tell right now index is 15, what is the next index? It will tell you. It need not be 16. Whatever in the list, whatever is there, it will tell you. Let's say I have chairs at 5, 17, 35, 64, and 99. For 17, what is the next index? 35. It is not 18. Because associative array is discrete in nature. So the index after 17 is 35. Index after 35 is what? 64, not 36. That is what next will do. What previous will do for 17? 5. So the previous returns the previous index value in the array for given index value. All the methods return output as output argument of the function. Function return value indicates pass fail status of the function. Function return value will indicate pass or fail status. Now, assume one associative array, packet associative array with Indexes 5, 12, 97, 315, 102. How many indexes are there totally? 5. This associative array has totally 5 elements. If I give num, int count index, let's say count comma index we have declared. This is wrong uses. Count should not be passed as an argument. It should be written as count equal to array name dot num. So the value comes as a return, not as an output argument. Did you understood why the first one is wrong? We are using that function in a wrong manner. It won't come as an output argument. It will come as a return value. Delete. What it will do? This one. Because you are not passing any index, delete all elements of the array. This will delete all the elements of the array. What this will do? If element exists at index equal to 10, understand, if element exists at index equal to 10, element is deleted. If element exists at index equal to 10, element is deleted and function returns what? 1. Because delete is successful, it will return 1. After delete, array will have 1 element less. If element doesn't exist, function returns 0 value. Okay, please read that once. Here, exists will do what? Associative array dot exists 5 means if it exists, it will return 1. Means in this case, what it will do? It will return 1 because there is an element at index 5. If the element exists at index equal to 5, this function returns 1, else returns 0. First will return the first index value. Okay. This is wrong usage. See, there are two different ways. In the case of num, it should be count equal to. In case of first, you have to pass it as an argument. Returns index equal to 5 since it is the first index. Packet associative array first is also possible. This is wrong. This you cannot do. Last, again for last also you have to pass index as an argument. Next, this is wrong. You should not pass a fixed value. You should always pass a variable name. If A is uninitialized, it is wrong. Index, if index is 5, then index gets updated to 12. We are passing index by reference here, not by value. Do you know in function we can pass a value by reference? No, right? I think we haven't covered that topic. We'll discuss that today. Okay. Previous. I'll explain this. Through that, we'll understand everything. We will take this example, this assignment example. When we do this, you will understand the concept of associative array. First, do what? Declare an associative array of data type, 9-bit vector, index type what? Integer. Name of the array is what? Bit vector associative array. Let's do that now. So whatever I'm doing now, I want you to try the same thing at home. Okay. End module. What is that index type to be? A data type should be bit 8 down to 0, bit vec associative array. Int, let's say. Int or integer. Right now, I'll take int. This is how you declare associative array. Please take a look. This is the data type. This is the index type. Can you see that? Data type is a 9-bit vector. Index type is a integer. what is that we want to do here? Allocate 10 elements randomly. Allocate how many elements? 10 elements randomly and store them to the array. Data values between 15 to 90 and index values from 10 to 30. Make sure that indexes are not duplicated. We should not duplicate the indexes. They should be unique indexes. Please read this question again. Allocate how many elements into the array? 10 elements. Fine. How do you allocate 10 elements? What should I do in the code? When I have to allocate 10 elements, what should I do? I should always write a for loop. To do 10 things, we need to write a for loop. I less than what? 10. I plus plus. Again, end. What should I do in this? Tell me. Data values between what to what? 50 to 90. Index values from 10 to 30. Clear, right? So now what I will do is data value I'll declare as 8 down to 0. Data. Index is what? Int, right? I declared two variables. Data and index. Data should be from where to where? Please read and tell me. So $u random range. Index from 10 to 30. From 10 to 30. What should I do in this case? Now, bit vector associative array index filling the array. Understood what I have done? I have generated an index which is between what to what? 10 to 30. Data from 50 to 90. So bit vector associative array of index equal to, we are filling the data. Now I can display it. Tell me what is the easiest way to display it? Fact %p. How many elements are there? Seven elements are there. What is the first index? 10 is the first index. 11 is the second. 15 is the third index. 25, 26, 27, 30. Totally how many indexes are there? 7. What is the value at the first index? 90. Value at the second index? 58. Value at third index? 53. Cut it. How many elements we wanted to actually fill? 10. But how many elements are filled? 7. Only 7 indexes are filled. Why do you think it happened like this? Instead of 10, why only 7 got filled? Not the reason is the index is duplicatedly generated. Same index got generated. Some indexes got duplicated 3 times. Because of that, instead of 10 elements, how many elements got generated? 7. So we'll display that also, you'll understand. 11 got duplicated. So because since you are using same index, first index gets overwritten, right? 11 gets overwritten. Again, which one is overwritten? 26 and 25. 10, no, 10 is only one time. It's actually 11, 25 and 26. Because of these, 3 elements got less. See, we ran the loop 10 times. Out of them, 3 duplications happened. So instead of 10 elements, how many elements will be filled? 7. So what should I do to solve this problem? Tell me. Solve this problem, what should I do? Should we do? Solve this problem. Exists, we have to check. We'll check if not of vector associative array exists. Index. Only then you fill it. It doesn't exist. You're checking what? If index doesn't exist in array. Only then you fill it. Not only that, what else should I do? Along with that, what should I do? I plus plus should be done here only, not here. My iteration should not go ahead. My index I should be incremented only if I'm able to fill the value in the array. Otherwise, my index should not proceed further. This will ensure that you're generating how many elements? 10 elements. Now if I run it, there is a problem. Let's see. What is that? This bracket is missing. And bracket is now count how many elements are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did you understood how 10 elements got generated? Got it, right? Because we are checking before you fill the array, you are checking if that array exists, that index exists, then don't fill the array. If it doesn't exist, how do you confirm that it doesn't exist? Logical not. Then only you put the element into the index. Then only you do increment. Here you're not doing it. Don't increment the index here. These concepts are very important. See, these are few concepts which will be applicable in many places. Okay. Your index, for loop index should not proceed unless you fill the array. We have used the same concept in, I think, Verilog also. We have used the same thing. Got it? So I have given the hint as what? You have to use exists. Next. Print all elements of array using what? Percentage. Now what did we use? Percentage P. What is the other one? For each. So let's use for each also. Can we use for each here? Yes. Simple. For each of bit vector of I begin end dollar display bit vector of percentage 0d equal to percentage. What should I write? 0d I comma bit vector of. You understood? Bit vector associative array percentage 0d equal to percentage 0d I comma bit vector associative array of I. If I run it now it will print in individual lines. What is the index value? See, at index 10, what is the value? 90. At index 11, 77. At index 15, 50. So whatever way you want, you can print it like that. Either you can print it in packed format, or you can print it in a for each loop, or even a for loop. How to write for loop? Tell me. How to write for loop? Can I write like this? For integer I equal to 0, I less than how much? 10, I plus plus. Will it be correct? Tell me. Is it correct? Tell me. If this is how the array is, 10, 11, 15, 17, 20, up to 30, tell me, is this code correct? Index value is not from 0 to 9. Index values are something else. They are not continuous in nature. Hence, I cannot use this kind of for loop. I cannot use this kind of. Do you agree with this? That is where I have to use the methods first, next. Which methods I have to use? The first and next. That is why they have given those methods. In static array, we don't need this. Why? In static array, what happens is we allocate in continuous manner. If index 10, next index will be 11, next will be 12. So you don't have to write next. You know that after 10, next index is what? 11. After 11, next index is 12. After 12, next is 13. So you know that. So now, let us understand how to use the method first, method next. Because you want to go first, next, next, next. Let's do that. This is wrong. So what am I going to do is it vector associative array. What am I doing? I'm getting the first index. Once you got the first index, you display it. You display it. Okay. Then important code. You see important code while bit vector associative array dot next index. That's all. This completes the code. Please understand from line number 22 to 26. Have you gone through this code? First thing we have to understand is we cannot use for loop because associative array is not ordered. Indexes won't be like 10, 11, 12. Then we can use. Does everyone understood why we can't use for loop? So what is the alternative? Either use for each or use the first, then use the next. Understand the concept. We are passing a variable. We should never pass fixed number. It won't work. If you pass a fixed number, it won't work. Here also, if you pass a fixed number, it won't work. Because how it works is, if the current index is, let's say 10, the next method will update it automatically as 11. Same index gets updated. Whatever argument you pass, that itself gets updated. Because of that, you should not pass a fixed value. You should pass a index, a variable name. Now, variable name could have been XYZ also. But it should be a variable, not a fixed value. Understood that? whenever you are passing this, you should not pass a fixed value like 11. Then 11 cannot update to 13, right? Because 11 is a fixed number. Because of that, you should pass a variable name. Now if I run, so I will display a statement saying that displaying using first and next methods. Let's run this. Fail to find I. Here it is not I, right? What is it? Index. Index. Index is index, right? Not I. 24. Yeah. Is it giving the same thing? 10, 90, 11. At 11, what is the value? 77. If I take this line, what is the index? The one inside the bracket is index. One right hand side is the value. Got it right. Now, in what order I have printed? From first to last. What if I want to print from last to first? First, I want to print the last value. Can you write that code now, everyone? Can you write it? That entire code I want you to write. I'll again repeat my question. Now we have used the first and next method to print the values in this order, 10, 11, 15, like that. I want you to write a code which will print in the reverse order. First, it should print array name 30 equal to value 56. Array name 27 equal to value 77. Like that it should print. Tell me. Not sort. Use the associative array methods. I'll show you the methods also. These methods. There are methods here. What methods will you use? Last and previous. Can you write it? So let's work on this. What is that? We want to print the array in what order? Last one first, then the till first one. So in that case, what will I do? Print in reverse order. I can copy the same code. What should I use here? Last. That's only same code. You just have to change the methods. Why I asked you to do is, I want to check, are you able to at least understand this code and replicate this code? Whatever code I have shown you, did you understood and are you able to replicate that code? No need to do now. See, even if you don't learn in the classroom, no problem. Going home, you should be able to at least try these things and able to reproduce this result. Again, I'll repeat, for you to get a job, no need to do any research and development, no need to innovate anything. Whatever being taught every day, let's say if I teach 10 problems in a classroom, go home and just practice those 10 problems 1 or 2 times. Every day, just follow the same process. After 6-7 months, you have a job. No need to do anything extraordinary. Whatever is being taught in the class, everything will be covered. In the class, every topic will be covered. You just have to go home, take 3-4 hours, practice the same thing without looking at my code or anything. Question yourself. That if you do, you get a job. Whenever you miss that flow, you get away from the job. I mean, your chance of getting job gets reduced. Now we will see the reverse order. Next, my requirement is collect all indexes and all the values into 2 different queues. I should declare 2 different queues. What is the first queue? Index queue. What is second queue? Value queue. I want to write a code which will collect the indexes into index queue, values into value queue. Tell me, how can I do it? A very simple code. You have to write the same for each loop. Whatever for each we have, follow the same thing. No need to display. Index q dot pushback I, value q dot pushback we are collecting indexes into index q. I is what? Index. If I is the index, what is the value? This is the value. If I is the index, array name of I will be the value that we are pushing into the value queue. Index into index queue, value into value queue. Once it is done, you can display them. Let's say you want to just display $display. Index q is equal to what? Percentage P. Is what? Value q. Just go here and declare the same thing. As I want to hold the indexes, index is of type integer, value is of type bit vector. So you see, understand, I should not use integer here because I know value is what? A bit vector. So I have to declare a queue of bit vectors. For indexes, it's a queue of integers. But you see, Clear to everyone? Now if I run this, I will see index Q separately, value Q separately. Can you see the index Q? 10, 11, 15, 17, 20, 23, 25, 26, up to 30. So on. Value Q also I see separately. Next. Same way, collect all indexes and values into two different dynamic arrays. Earlier, what did we collect into? Q. Now I want to collect into what? Dynamic array. What should I do to collect into dynamic array? Can I use pushback? So how can I do that in that case? Tell me, what should I do? I have to collect into dynamic array. So here I declare it as dynamic array. Just paste the same thing. Remove dollar, change it to dynamic array. Change dynamic array. You understood? Instead of Q, I have declared dynamic array of value and dynamic array of index. Now I want to collect into dynamic array. What should I do? Same code. Very simple. Int dynamic array of I equal to I, not I. Sorry. There's a mistake. I'll explain. Use J. J equal to 0. Please go through this code. Let me know if you have any questions. Here it should be changed to. Yeah, we have to do that. Let's take a look from line number 49 to 56. In Q, it was easy. We don't need to do new, first of all. We don't need to use any index. Pushback will automatically push it in the order. We have to use J equal to 0. Initially, first element will be put at what index? 0 index. Next, what should I do with that index? Plus, right? Increment by 1. It should become 1. Next element should be put at index 1. Next, again, increment by what? Plus 1. Like that, totally 10 elements will be put at 0, 1, 2, up to 9th index. Okay. Let's run it now. J I haven't defined, so I have to go up and declare int J. As index is what? Integer, right? So I declare it as a int J. You see that also printing? Okay. Ideally speaking, I don't want to do these questions in the classroom. I mean, I want to give it as a homework and ask you to do. But my experience is that people don't try at all. Please practice this. These are important. They'll get used to, they'll help you get comfortable with for each loop, for loop, how to work with the dynamic array, how the concept of index works. The concepts will come, means you do 3-4 times, you'll get used to it. Even when I started coding, I was very new to coding, very, very new to coding. Then gradually, as I started practicing, started doing things, I started learning. So same thing you have to do. Okay, let's do the next one. Can you do the next one? How about fixed size array? Can you tell me? How will you do? Same thing, declare static array, first of all. Then only difference is what? Only difference is what? Tell me. During the declaration, declare 9 down to 0, 9 down to 0. If you declare 9 down to 0, you don't need to do these 2 lines. Rest all code is same. Rest all code will be same. Got it, right? Write a logic to print associative array elements in the increasing index order. That we have done right now. What is the methods did we use for that? First and next. Print elements in the reverse order. Last and previous. Okay. So please redo this entire assignment. Okay. Even if it takes one full day, like I did in half an hour, even if it takes one full day for you, please do that. This will help you, really help you. Okay. Again, to get a job, you don't need to do many complex things. Simple things, basic arrays, for loops. Simple logic should be, fundamental should be clean. When you go to interview, the focus will be on fundamentals. Okay. Next, we have discussed different types of arrays. Static array, dynamic array, associative array. Where to use what type of array? Where should I use associative array? Where should I use dynamic array? Where to use static array? Let's discuss that. Various arrays are used based on the specific application. Based on your application, we'll choose. Okay, if I know that, for example, in this classroom, if I know that every time 100 students will come. Okay, I'll go with what type of array arrangement? Fixed size, because I know that 100. If I know that any range from anywhere from 30 to 100 people can come. Anywhere from 30 to 100 people. So what will I go with? Dynamic array. So then I can give size anywhere between 30 to 100. If I know that though room capacity is 100, only 5 people will only come always. They will sit in random locations, not in continuous. I'll go with associative array. You see, in this example, same training, same classroom, but we had different requirements. In one case, always 100 people were coming. So we went with static array kind of declaration. In one case, number was varying. The third case, number was fixed, but they were doing in random locations. We went with associative array. Similarly, here also we have different requirements. Let's say you're modeling a small memory. Use packed and unpacked array, something like this. You declare like this. Because it's a small memory, just declare it. Memory is addressed by byte address. You're modeling large memories. Use associative array, because you cannot declare entire size. It will take up a lot of memory in your RAM. If I run with this one, even now if I run a system Verilog code, this line, my laptop will hang. Why it will hang? What is this depth? Tell me. 7, right? 7 zeros are there. Means what? This is what? How many bytes is it? How many bytes is it? Bit 31 down to 0 means 4 bytes. 4 into 10 to the power of 7. What is it? 40 into 10 to the power of 6. This is megabyte. 40 megabytes. That much space it will take. In my laptop, it is taking 40 megabyte space for storing one's memory, will make my laptop hang. You may say it has got 4 gigabyte or 8 gigabyte, right? Why it will hang for that? Because the amount of memory they would have allocated to QuestaSim will be very small. Some amount, because my laptop has a lot of other applications running, operating system, the presentation, GoToMeeting, this application is also running. All of them are running in my RAM only, DDR only. So amount of memory they would have given to QuestaSim will be small, some amount. In that, if you consume 40 megabyte, it will crash that application. That application will hang. Hence, in those cases, I don't want to do, I'll declare like this. I'll declare index as what? associative array. So what is exactly you required, that only will be used. Whatever you allocate, that only will be used. You're modeling a packet or a frame, use packed array, because entire packet will go into one same location. Packet fits into one location only. Both the dimensions will be packed. Whole packet or frame needs to be stored in single address location. Hence, use complete packed array only. Fixed size packets to be accessed sequentially. Use what? Fixed size array. Variable size packets accessed sequentially. Use what? Dynamic array or queue. Queues are used when number of elements can grow or shrink, and we need search and sort functionality. Go for what? Queue. There will be some type of memories called as content addressable memories. They will be implemented using associative array. You have command name and the value from a file. Then use what? Associative array, using command as the string index. This will complete this topic. That will stop. Let's quickly revise once. If you are modeling a small memory, you go with a fixed size array, packed and unpacked dimension. If you are modeling a very large memory, use associative array. If you want to model a packet, USB packet or Ethernet frame kind of thing, use packed array. Entire thing should be packed. Elements need to be accessed sequentially. I know that array size is fixed. Then go for fixed size array, because if the element is fixed in size, array is fixed size array. If I want size to increase, decrease, and sort and various functionalities we want, go with a queue, either dynamic array or queue, like that. You choose based on those requirements. It is something you learn with the practice. My personal choice is either use queue or associative array. Why I will prefer queue? Because it's not about declaration. First is you don't need to do new. Second is it has got so many methods. So many methods are there: push back, push front, pop back, pop front, reverse, insert, shuffle, delete. It makes it very powerful. If I take dynamic array, so many methods are not there. For example, I want to insert something into the dynamic array. In the previous session you have seen, right? It's not very straightforward. In queue, it's very, very easy. You just have to say insert value at specific index, that gets inserted. Those all features makes working with queue easier. So given a choice, anytime I prefer using queue instead of dynamic array, because whatever you can achieve with dynamic array, you can always achieve with queue. Queue can do things more than what dynamic array can do. In the other cases where associative array is required, there is no option. So I only go with two options always, either queue or associative array. And if I know that size is fixed, I go with fixed size array. I very rarely use dynamic array, because all the advantages of dynamic array are there in queue. Let's do little bit revision of memory declaration. This is something we have done already in Verilog. Nibble means what? 4 bits. Byte means 8 bits. Half word means? Word means 32 bits. Double word means 64 bits. Can you do this? Declare a byte address memory of 64 locations. Can you declare that? Byte address. Each byte has an address. Each byte has a address. Can you declare byte address memory of how many locations? 64 locations. Once it is done, we'll end the session once this topic is done. This is the answer. This is the answer. Byte address memory means what? Each byte has an address. Name of the memory is mem. How many locations? If I had told integer address memory, I should have written int or integer. Each integer has an address. Word address memory of 128 locations. Word means how many bits? 32 bits. Please do that. What should I write instead of byte? Is there a keyword called as word? What will I do? Bit 31 down to 0. Here 127 down to 0. Okay. Next, declare the payload of Ethernet frame which has variable size of 42 to 1500 octets. What is the payload? Variable size. As soon as variable size comes, you have to declare it as either dynamic array or a queue. What is size between 42 to 1500? Like this you declare. See, purposefully we are making it unpacked. The reason is we can't have packed dimension for dynamic array. See, dynamic array cannot be packed right here. You cannot even have a queue dimension here. It always has to come on the right hand side. This is not possible. Got it, everyone? Declare SOF packet in USB, which always has 3 bytes only. If it has 3 bytes, 2 down to 0, second dimension is what? 7 down to 0. So 2 down to 0 means 3, 7 down to 0 means byte. So totally 3 bytes. Declare a USB packet which has 128 nibbles. Reg 127 down to 0, 3 down to 0. Whole USB packet is stored into single address location because it's a packed. It is always stored in one address location. What is that I'm showing here is how to declare different types of arrays based on the given requirement. So this is about arrays, static arrays, dynamic arrays, and associative arrays, and how to work with associative arrays, how to declare, how to fill, how to use exist method, first, next, last, and previous, all those methods, how to display an associative array. Then we also discussed about for different applications which type of array to be used. It is something you don't kind of memorize. It comes with practice. When you are working in a specific application, you will know that here associative array will suit. For this requirement, queue will be suitable. That should come as you practice more of this, it will come automatically. Okay. So we will stop the session here. In the next session, we'll be talking about operators. Just before we start, all I want to tell is everything, most of the operators we are discussing here, we have already studied in System Verilog. Sorry, in Verilog. Means, except for the red color ones. Did we study assignment operator? Yes, right? In Verilog we have studied. Condition operator, unary, binary, unary, module path, logical, shift, arithmetic, concatenation, replication, all of them. These are the new things. So these are the new operations also. Few things that are there in System Verilog. So our focus will be on these newly added operators. We won't be really going through much of this. I mean, I won't be spending a lot of time there because we have already done it in Verilog. So what I want you to do is I want you to go through Verilog presentation or assignment, revise these things once, little bit, so that when I cover them at top level, you will understand. I'm not that I will not directly jump here. I'll go through them, but you coming prepared will help us do it quickly. So let's end the session here. So once the will be kind of completed with the essential topics, then we can start with the object-oriented programming. But before that, we'll make sure that you are all done with those assignments, before we start with object-oriented programming, we'll ensure that you are good till operators, means the data types, the arrays, and the operators. Those topics you should be comfortable. Then only we'll move to the object-oriented programming. So let's end this session. What topic is happening in the assignments now? Arrays, is it, or which topic? Fine.
This conference is no longer being recorded.
So